All right. Good morning, good afternoon, good evening, wherever you are in our virtual world. My name is Ron Dagdag, and today I will be talking about making neural networks portable with ONNX. Let's get started. If you are interested in getting the slides or the demo that I will present today, uh, feel free. You can actually get them on. It is on my GitHub page. If you want to scan that, I will also display this QR code later on in case you need to reference it later. All right, let's get started. Today, uh, the other day, when I was trying to prepare for this demo or for this presentation, my son, my 11-year-old son, he asked me because he overheard what I was talking about. He asked me, "It's like, Daddy, are you gonna be talking about Pokemon?" And I was like, "No." So if you are a Pokemon fan out there, I am sorry to say that I am not gonna be talking about Pokemon Onyx. I will be talking about Onyx. I will not, if you are a geologist and you're talking about the mineral onyx, I am sorry, I'm not going to be also talking about that. I will be talking about onyx, ONNX. So, and also about bread. If you are in the chat right now and you want to participate, feel free to type on the chat what is your favorite bread, just to keep things light around here because our topic is going to be interesting today. So let's go back to programming. Uh, Typically, when your boss tells you, "Hey, create me a program for these automation or something," right? Like in this case, we're doing a calculator. So what do we need? Two things we need is what are the inputs, how to get the input, and then algorithms. The formula that we need to implement, and then of course we display the answers. That's our typical way on how we do programming. In the machine learning world, it flips. It's the other way around. What the goal is to be able to teach the machine to create an algorithm for you. And what you would need is to have a bunch of input, a bunch of examples, and a bunch of answers, right? So you have an input, you have answers, and the machine would understand or would find the patterns against that, and it would create an algorithm for you. So as a machine learning primer, programming on the right side, you have algorithm, input, and answers. On the left side, that's your machine learning, where you have answers, input, and algorithm. And most likely you're familiar with this. Uh, when we call machine learning, in machine learning world, we call that training data. And then you would need a training framework in order to build a model for you. And then that model, you would exchange it to uh, your algorithm. And in order to use that model, you need, and that's what we typically call inferencing. And then we need an inferencing runtime in order to consume that model and answers. Today, Onyx, we're going to be focusing on this side of the house, the inferencing side, where you have an input, the model, and you would use a runtime in order to uh, incorporate it to your application. Okay. And of course, as a feedback loop, the more you use this application, the more training data you can have later on to improve the model. So typically, if you are a data scientist, most likely you've worked with PyTorch or some machine learning framework. you write it on your computer and it's running on the CPU. But of course, just like any, uh, if you come from a JavaScript world or those JavaScript frameworks, there's a lot of them. And of course, in machine learning world, also there's a lot of these frameworks in order to train and build your model. There's when we talk about Keras, TensorFlow, scikit-learn, and all these different applications out there. And then when we try to deploy these application or these models, right, we would sometimes run it on the CPU, GPU, or FPGA or ASIC. Sometimes we want to run it on the computer or in the cloud or in the phone or an IoT device. And so ONNX is the bridge between, being able to generate or create that model in a format that can run on the CPU, GPU, and all these different processing units. So think about it as kind of like a PDF, right? You may wrote it on Microsoft Word, or sometimes, like in this case, I wrote my presentation in PowerPoint. I exported to PDF, and now you can consume it anywhere you need it, and that can have the viewer, the PDF viewer. So that's the way I kind of see how ONNX helps you also in terms of the models itself. So ONNX is Open Neural Network Exchange. It is open source on GitHub, and it's an open format for machine learning models. The best place to start learning about it is ONNX.ai. And it started by collaboration between Microsoft and Facebook, but through the years, it has grown that other companies have also integrated or contributed into this open source project. So every time I would write this presentation, I would update these link because there's more and more partners coming in. It is, like what I said, it's on GitHub, about 11,000 GitHub stars, 2,000 pull requests, 200 plus contributors, about 2,000 GitHub forks, and also about 40 plus model zoo. I will talk more about that later on. What is a model zoo? It is a graduate project of Linux Foundation AI. So what that means is it is ready for production. Now that we did talk about what is ONNX, I will talk about when should you use ONNX, and then later on how to create an ONNX model, and then how you can deploy ONNX models. So when should you use ONNX? When you have something that is typically trained in Python, because a lot of those machine learning frameworks, are targeted in that runs in Python. And then now you want to incorporate it to your application, like deploy it with your C# or Java or JavaScript application. Another one is when you need something that is that needs high inferencing latency for production use. So you want something really fast, and it makes sense to have something that's very optimized for that device. When you have a model that you need to run on a resource constraint IoT or an edge device, one good example of that is this Azure Percept device that is constrained, that is an IoT device, and the data scientists may have programmed their application on maybe on their laptop or like in the cloud, where they created that model that has a lot of resources, and then maybe it was written on Windows or in Linux box, and now you want to run it on a different OS or different hardware. That might be a good example of how you would need to convert it to ONNX. Let's say if you wanted to run it on an ARM processor, or you want to run it on let's say on a Linux device, or not just on a Linux device, but maybe in a mobile app. Also, when you want to combine running models that are created from different frameworks, let's say you have a large team of developers or data scientists, and they all have their skill set, right? They know where to use the right framework in which one to generate that model, or however they are comfortable with. But you want to incorporate it to your application, but run it in the same platform, or meaning kind of combine them together. Also, when training takes too long, that's when we start talking about transformer models and being able to train locally. Okay, let's move on to our presentation. So there are different ways in how you would create and how you would deploy to devices. First, let's start with creating. Right, let's focus on that. So last year, when the pandemic first started, most likely you remember it. And remember that time when it's kind of difficult to go to the grocery, and pretty much a lot of the supplies are. So my wife and I, we started to experiment, cook or bake some bread, and it is our first time to bake bread. Actually, we've been married for more than 10 years, and it was a gift, a bread maker. They gave it to us, and of course, we haven't used it in a while, and we started using the bread maker in our first time to bake bread, and it didn't come out right, and we didn't know what's going on, what went wrong, what happened. Come to find out that we used cold water for the yeast, and it didn't turn out like bread at all. And so we learned through time. So my point is on this is that the data scientist in your company, it's kind of like they are the ones that find the secret recipe for your company. They try different experimentation. They try different you know ingredients, right? Different data sets in order to reach a goal, right? To maybe some automation or something that would improve the business. So there are 4 ways on how you get an ONNX model. One is through ONNX Model Zoo. Another is through Custom Vision Service, converting it from an existing model, or trained using Azure Machine Learning or automated machine learning. So ONNX Model Zoo, it is on GitHub if you want to download some of these models. These are models that are already trained and available for you. It may be and it got converted to an ONNX format. So this way you can download these models and then incorporate it to your application. So if you're talking about ResNet, SqueezeNet, MobileNet, most likely if you're for image classification models, check if it's available there, and you can start trying it out.
I have a question there.
Sure.
So if I'm a Python developer used to Azure Machine Learning SDK, there you can create models, export them with a specific extension. I don't remember which, Can I convert those to ONNX?
So I know you can do ml.net and convert it to ONNX. So
Okay.
it's not just limited to a Python model, right? But a lot of them right now, they were written in Python. That's the whole reason why. But later on, I'm going to show you a demo on how I was able to convert an ml.net model and then save it to ONNX.
Okay. Thank you.
You're welcome. So there's, like I said, image classification. There's also, you know, different types of object detection and different models that are available out there that got converted to ONNX. Another one is through custom vision service. So it's where you can upload some of these images. In this case, we are uploading images of fruits, and we tag them, hey, these are fruits. And then, we try to classify uh, different types. And then we click train, it would learn from those images and then create a model that we can export and download it to ONNX model. And that's how easy it is to get started on this. So, I started talking about ONNX model, and it is a graph of operations. There is an application that is available on GitHub, netron.app, that visualizes what an ONNX model looks like. And this, let me just see if I can pull up this. So this one right here is a sample of ONNX model. This one is the emotion that I downloaded on the Model Zoo, emotion fur plus, and it gives you like the list of operations. So the data would flow from here, and it would run from this operation down to until it gets to here. So the advantage of using this Netron app, it allows me to be able to know what is the input of this model and then what is the output of it. In this case, there's one input that I need. It tells me that I need a 1 by 1 by 64 by 64 matrix. And then it would spit out a 1 by 8 matrix. Cool. So as a software engineer, it allows me to know what is the input of these if I need to consume it later on, and what is the output. But it tells you what the commands that is actually running. So if it's a convolutional network, and it has some of the graph of these operations. All right. Another way to generate an ONNX model is to convert it from, let's say, PyTorch to ONNX, or TensorFlow to ONNX. So here's there's 3 steps involved, and there's tutorials out there on how you would do it on these different frameworks. First is load an existing model in memory, convert it to ONNX, and then save it to an ONNX model. So for example, in PyTorch, you would import the torch.onnx package, load it to the model into memory. And once you load it, give it a sample input. Like in this case, this model requires 1 by 3 by 224 by 224 image. And then in this one, now you can export that model into the file. There's also command line, like in this case, if I want to convert a TensorFlow application, a TensorFlow model, I want to convert it to ONNX, you can do that also. So let me give you an example what that looks like. Let me go back here to my node application, and I will go to this Jupyter notebook. On this Jupyter notebook right here, actually, go back up. Let's try to run it locally. This one is a Jupyter notebook running on Visual Studio Code. It's using .NET Interactive. So that means I'm writing a C# application right here. I have some NuGet packages that I import. And then we are going through each one of these. First things first is how do I load the data? So my salary.csv, this is what it looks like. I have two columns, years of experience and then salary. So what I want to do is the simplest regression. And so I load it through a data frame. I have my data. There's a sample of data that I have. Remember, we have input and then output, so that we can have, we can teach the machine how to predict. So this is my description. And so what I did here was to kind of randomize with the data the training data and the test data, and kind of split my data set. And then I'm using ML.NET. Of course, there's a pattern. Every time you use ML.NET, you need the ML context first, and then you create a pipeline. And what that pipeline looks like, in this case, we are using regression trainer. We specify what is the label column, and we want the salary as our label column, and our input is years of experience. And once we have a pipeline, then of course we create the model. There's always that pattern, fit, and then transform. So you pass your training data to your pipeline. It would create a transformer. It would create the model for you, and then you can evaluate using transform and pass in your test data set, and that will give you some metrics that you can display and kind of understand what how good your model is. For us, what we want to do is to save it to this model.onnx with that data set. So in order to save it to ONNX model, we would do context.model.convert to ONNX. We pass in the model, the sample data, and then stream, and that would create the file itself. And then now I can view it on Netron. So I did capture a screenshot of Netron, and so it would tell me right here, since we didn't create a neural network here, I just created a classical machine learning. Notice that it needs two things in order to run this model. In order to use this model, you need years of experience, and then salary. Even though it's not being used, you still need to pass it as an input. And then on the output, what we really want is the score.output. The rest of them, it just passes through. And so you need score.output and get that data and get that result. Okay. So what just happened? We generate a regression model. We export it to ONNX. You can also use ONNX as an intermediary format. So where you can convert, so you can, if you want to use ONNX to convert, you have something that is written in PyTorch, and you want to run it on Android. So you want to use ONNX as intermediary format, so where you can convert the PyTorch model into ONNX, and then from ONNX to TensorFlow. So you can convert back from ONNX to TensorFlow. Another one is if you want to run it as part of Core ML, you can convert from, let's say, in PyTorch to ONNX, then ONNX to CoreML. You can also use ONNX model as a base for transfer learning. So you can do fine tuning on an ONNX model, and there's some tutorials out there on how you would do this. And here's a good link in order to understand more about these. You can also train models in the cloud where you can experiment locally, then quickly scale to the GPU clusters. You can also use automated machine learning and hyperparameter tuning, be able to track experiments, manage the model, and easily deploy them as as part of your CI/CD tooling. What I'm trying to say is that uh, you can experiment locally on your machine, but you can submit it in the cloud where you can train and test your model. But the important part is let's say you have this ONNX model and you have a new experiment and you have a new model. How can we start versioning these and have a model registry? Just like you have your Docker registry, right? Your container registry. You also might need to look into model registry, and that can know which version and which. And then once you build the image, kind of map that from the model registry and how you would deploy it as a service. So now that we know how to create a model, next step, once we have an ONNX model, we can deploy them and integrate it to our application. So, baker, what is the difference between a baker versus starting a bakery? So, baker, the answer is you need different skill set in order to be good at both, right? Baker focuses on like building the best recipe, just like your data scientist, your team, they find ways on how to create the secret recipe. But if you're starting a bakery, it requires a different skill set because now you have to think about, well, how do I collect payments? How do I put the supply chain together, right? How do I automate this whole system, or where do I place the chairs, and how do I lay out the bakery? So there are different things that you have to integrate as part of your application, right? So I come from a software engineering background, and when I first started looking at data science and started looking at, hey, I want to learn about machine learning, I want to learn more about these AI stuff. Data is very critical as part of it. And then of course, creating the models. But when I started looking at more and more, where does AI provide value? AI can only provide value once we start integrating it to applications, once we created applications around it. And so more and more I think about the value that I can provide as part of these is to learn more how to start integrating it to not just existing application, but also to new applications I built. How do I put AI on these? And that right there provides the value of all these new and upcoming technologies that are that has an AI component on it. So of course, there's different frameworks, and you can convert it to ONNX models, and you can use Azure Machine Learning. You can deploy it to Ubuntu or Windows Server as native support. You can deploy the ONNX model to IoT edge devices. Of course, we did talk about those converters that you can now you run it on iOS, or you want to run it on the Android devices. Of course, whenever we talk about deploying these machine learning models, you got to think about, are you running it at the cloud or at the edge? Edge meaning how close is the data processing to your users. So deployment in the cloud, most likely we're already familiar with it, where we deploy it as a web service, and you can integrate it to your application. You may have model management. We did talk about model management, where you have a model registry and be able to know which web service uses which model, right? And then you have to capture model telemetry, the usage, how good it is, and how well it's giving the feedback. Yeah, and that's this part right here on the right side, where you have the model management, and then building the image, and then deploying it and monitoring that model. So what is the edge? The edge is, like I said, it's how close it is to the data processing to your users. So the cloud, typically we already know that those are the data centers, the regional data centers. You have your Azure cloud, or maybe GCP, AWS. And then of course, there's edge nodes, where is sometimes we call it fog. If you think about those 5G networks and the cell towers, where you can deploy some of the data processing there, right? And that is closer to the user. But what is much closer are these edge devices. Think about the phones, or think about these IoT devices. Think about the gateways that is close by. Uh, so whenever we're deploying to the edge, now with the cloud, we're talking about thousands of devices. At fog, most likely millions of devices. Edge, billions of devices. So that's just gives you the scale of how you would have to manage your models if you were deploying them different areas. So why would you run AI on the edge? First is low latency. You want it really fast. Think about it. If you have a camera, each frame you want to do some machine learning workload there. Instead of uploading each of the images to the cloud, you can run it locally, and it'll give you the result. Of course, because of that, it saves a lot of money, because if the device is already capable, then you can run the machine learning model at the edge or at the device, instead of running it in the cloud, and it would save you some ingestion cost and processing too. And then of course, flexibility. Let's say if you're on if you lose internet connection, or the internet connection is really not that fast, app still works, right? It's still available, and still is able to process some of the data. And also, there's some rules that you cannot just share images outside of the network, right? Because of let's say, depending on where you are in the world, right? And running it more and more locally, it makes sense in terms of privacy. And so there is this high performance inference engine for ONNX models called ONNX Runtime. It is founded and open source by Microsoft under MIT license. It's not just supports neural network, it also supports traditional machine learning spec. It has extensible architecture for hardware accelerators. That means you can run it on GPUs, CPUs, some VPU or other processing unit, and then it actually ships on Windows 11 or Windows 10 as WinML. And to learn more about ONNX Runtime, the best place to go is onnxruntime.ai. So if you go there, you'll see this. Notice how it would ask you, like, what type of platform are you working on? Like in this case, I'm going to do a demo today on how you would run this on a web browser. And then let's say in this case, of course, we can run it as JavaScript. And then, of course, it doesn't matter what architecture it is. So if it runs on x86 or ARM, there's already cross-platform, and hardware acceleration is not needed. But let's say if you're on Windows and C# and you're running it on an x64, x86, and then you want to run a CPU, it tells you right here what are the instructions on how you would incorporate that. So it kind of helps you understand, the first step you need to take, right, to get things started. ONNX Runtime Web or ONNX Runtime JavaScript. There's 3 ways in how you would do it. You can use node.js binding. There's a way you can incorporate ONNX Runtime in Node. Also, you can run it on the browser, ONNX Runtime Web, and then you can also use ONNX Runtime as part of your React native application. So if you want to run it on Android or iOS. So ONNX Runtime Node, it's specifically for as a Node.js binding for ONNX model inferencing. It can easily integrate with your Electron app, and it does use WebAssembly in the background. To use it, you do npm install ONNX Runtime Node, and then you can import that ORT. Okay, so let's go a little demo on how we would use it. So remember, I created this model.onnx on my notebook. I will go to this node application right here. I copied that model ONNX to my node application. Notice how I have my package JSON right here, and it has this dependency ONNX runtime -node, and I'm going to run index.js. And on this index.js, I require this ONNX runtime node, and then I call it. So I load the ONNX model to this session, and then remember, I need to pass in 2 things to my model. Just to go back to this image right here, we need to pass 2 things: years experience and then salary, and then our output would be score.output. So years of experience, I need to identify a value. Salary, it could be 0. It's going to be ignored anyway. So let's say I have, not 100 years, right? Let's say 10 years. And then I convert that to a tensor, passing in that years of experience. Remember, it requires a 1-by-1 tensor. On the tensor salary, it's also 1-by-1. Even though the image says -1/1, it's the same value. So now that I have tensor years and tensor salary, I can create a feed, and that feed, I need to create the years experience and salary. How I knew this years experience and salary, because looking at the the name of the input. is years experience and salary. So that allows me to create that feed. I pass that to my session.run, and it'll give me the results. And then based from that result, I only want score that output, spit out that data, and it'll give me the value. So let's try to run this. Run this, say node. Let's see if we can read that part. Okay, where's my, let's try to run it again. So notice how the value is the resulting tensor. It gives me the results of that regression. So 10 is 120 or something, 120,000. So it gives me a value based from one input. Cool. So that's the simplest way on how you can incorporate node, incorporate ONNX model into a node application. Okay, let's go back to the presentation. There is also ONNX Runtime Web, sometimes called ORT Web, which is a JavaScript library for running ONNX models in the browser. It uses WebAssembly and WebGL technologies, and it's optimized to ONNX models for both CPUs and GPUs. So why would you want to do inferencing in the browser? One, of course, it is faster to execute. It works offline, so if especially if it's a PWA application, you might be able to run some inferencing locally. It's safer and it helps with privacy, and also it is cheaper to execute. Why would you not run your model in the browser? When the model is too large and it requires hardware specs. So once you convert the model into ONNX, check how large the model got generated. And now you have to think, when do you update that model? When do you download that model to the application, to the browser, and then execute it? And then sometimes it takes longer to download that onto the device. So that's when you have to consider running on the server side or the device side. So let's look at some examples real quick. So going back here, I have my browser application, and this browser, I will use this ONNX model called Emotion Fur 8 ONNX, and we did look at that on our we did look at that on Netron, where it needs two inputs. I have my index.html, and what this index.html does is I have a script tag that uses the CDN to reference ORT ONNX runtime JS, so I can integrate it to my application. And then I have some format, and then I will look at this main.js. I did run this application already. This application, look at the package JSON, it's just running locally using live server. And then in order to run it, I just have it in a specific port and then running it locally. So it looks something like this in my local host 8081. And what I need to do is to load an image. It would load it here. It would display the image. It would scale it to what the ONNX model needs, and then it would give me the results. So let's start with that. I will have the image of this crying baby. Just in case my demo doesn't work, I am covered to cry about it. And so this one allows me to read upload that model, or upload the image. And then once I upload it, let's see how it flows. It would go to this unload image, and I will handle it. So let's move there. So the image is loaded. Let's see what happened. So I will process that image. What I did here was it needs 64 by 64 and the grayscale image. So 64 by 64 and 1 by 1 image. So I resized this image to 64 pixel by 64 pixels, and then I need to convert it to grayscale. And how I converted it to grayscale, there's a formula that I used, and that I found out that it runs better when there's different ways in how you can convert an image to grayscale, but it seems like this model performs better if it looks something like this, grayscale. So once I convert it to grayscale, now I can convert it to a tensor. And once I convert it to a tensor, so let me show you what that looks like, how you convert image to a tensor. So this, just going through that data, make it a float, 32 array, and then use ORT tensor. You specify what type of data and the dimension. The dimension is 1 by 1 by 64 by 64, and that's what it needs in order to do it. And then now that it's ready to go, I can go here and say load the model, ORT.inference session.create. Once I load the model, I need to create the feed. And then this time I need input 3. How I know that input 3? Because looking at this, on Netron, I need to specify input 3 with that parameter. Come on. And then I send, or I feed that into session.run. It'll give me the result. In this case, I know the classes, right? It's neutral, happiness, surprise, sadness, etc., for all those 3 items that it would result. And then it would give me, then I can map and get the highest value on the output, and then I can get my prediction. In this case, it resulted back to sadness. So let's try it again with a different image, like in this case, surprise. And then run it through, convert it to grayscale, convert it to tensor, pass it here, load it, pass it to session.run, and the result would look something like this: output data, right? So notice that it just grabs the highest number out of this list. In this case, this is the 3rd item on the list, which is surprise. So it will print surprise. So that's what the image got scaled, and it was surprised. Cool. What just happened? What we did was to use something from ONNX Model Zoo. We uploaded the image. We know the requirements of that model. We use ORT Web, or ONNX Runtime Web, in order to integrate it and do inferencing on our web application. All right, let's go back to the presentation. React Native, you can score a pre-trained ONNX model, and where you can have a lightweight inference solution, and you would need to use ONNX Runtime Mobile in order to do this, in order to uh, optimize more that ONNX model to run on Android and iOS. So you would use npm install ONNX Runtime React Native in order to do this. And the important part here is you would what it does is it minimizes the binary size to a pre-optimized ONNX model called ORT format. And that's how you would integrate it to your application. There is a tutorial out there on the docs. If you go to onnxruntime.ai, that would walk you through step by step on how you would do this. In terms of the compatibility chart, Chrome, it runs WebAssembly and WebGL on Windows 10, Mac OS, Ubuntu, iOS, and Android. At the edge is about the same. Safari, you would use WebAssembly and WebGL. On an Electron app, you can use WebAssembly and WebGL. If it's a Node application, you would use WebAssembly. All right. And of course, it feels like this after talking about all the capabilities of how you can use ONNX model into your application. Just to recap, what is an ONNX model? It is an open standard that you can use the right tools for the right job, right? And you are confident enough that it would run efficiently on that target platform. ONNX models can be created from different many frameworks. How you would deploy it, you can deploy it using Node, web browser, React Mobile, using this high performance ONNX runtime. That's it for my presentation. If you want to learn more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacey. I'm a 5th-year Microsoft MVP awardee. Best way to contact me is through Twitter and LinkedIn. Or if you want to know all my social connection, linktree / Ron Dagdag. I appreciate you geeking out with me about ONNX, about baking bread, and about different types and how you would incorporate to your JavaScript application. Thank you very much. Are there any questions out there?
Thanks a lot, Ron. No, I don't see any questions here at the moment. Many people they watch these videos on demand.
Yes.
But it's really interesting. My head exploded. Like
Yes, and if you have any questions, feel free to contact me through LinkedIn and Twitter. And if you want to give me feedback about my presentation, I appreciate you contacting me and sending me a feedback on how you learned or what you learned about this, and if I helped you in the future about my presentation. I like to hear from you.
yeah, I just added you to LinkedIn and follow you on Twitter also.
Cool.
So we can get in contact for any group work or any.
Yes.
Okay, thank you very much. We are waiting now for the next speaker.
Cool.
Thanks.
You're welcome.
Bye.
Bye.